The journey of the unpickable lock begins not with a key, but in the suffocating heat of the forge, amidst the acrid smell of sulfur and the rhythmic, deafening clangor of the trip hammer. In the year 1700, a master locksmith does not trust the common brittle iron sold by local merchants. He demands the finest Swedish Öregrund iron, known for its superior purity and fibrous toughness, essential for a mechanism that must withstand both brutal force and the ravages of time. The apprentice's day starts before dawn, managing the bellows to coax the coal fire into a white-hot rage, ensuring the temperature is precise enough to soften the metal without burning the carbon out of it. There is a visceral physicality to this stage. The master manipulates the glowing billet with long tongs, striking it with calculated violence to drive out impurities and align the grain of the metal. He is not merely shaping a box, he is forging a fortress, flattening the red-hot bar into a heavy, flawless backplate that will serve as the foundation for the entire mechanism. Every hammer blow must be true, for a single hairline crack or a pocket of slag in the plate could compromise the alignment of the delicate tumblers and springs that will soon be mounted upon it. Once the rough forging is complete, the work shifts from the violent energy of the anvil to the grueling discipline of the bench vise. The iron plate, now black with oxidation and cooling scales, is clamped tight, and the master picks up his coarse bastard file to begin the arduous process of surfacing. This is a labor of immense patience and muscle memory. The sound changes from the ringing of the hammer to the rhythmic, rasping shriek of steel biting into iron. He files in a cross-hatch pattern, checking the flatness constantly with a steel straight edge, seeking a surface so level that it creates a perfect seal against the future cover plate. This flatness is not purely aesthetic. It is an engineering necessity to prevent the insertion of thin picking tools or the accumulation of moisture that leads to rust. The workshop air fills with the metallic taste of iron dust, which coats the locksmith's hands and face in a glittering grime. He drills the mounting holes using a bow drill, feeling the resistance of the material, judging the quality of the metal by the way the shavings curl. If the iron is too soft, it will wear quickly. If too hard, it may shatter under the stress of a crowbar. He is walking a metallurgical tightrope, relying on touch and sound to certify the integrity of the lock's skeleton. With the backplate prepared, the focus turns to the rim, the walls of the lock. A strip of iron is heated and bent at precise 90-degree angles to form the enclosure, a process requiring an intuitive grasp of geometry to ensure the corners are square and the dimensions match the heavy oak door or chest for which it is destined. The master brazes the rim to the plate using a mixture of brass and borax flux, heating the assembly in the forge until the brass flows like liquid gold into the joints, creating a bond stronger than the iron itself. There is a distinct danger here. Overheating will warp the carefully flattened plate, ruining days of work, while underheating will result in a cold shut, a weak joint that a thief could pop open with a chisel. When the piece is pulled from the fire, glowing a dull cherry red, it is buried in warm ashes to anneal, cooling slowly to relieve internal stresses. As it sits cooling, the locksmith wipes his brow, knowing the brute work is done. The heavy lifting is over, but the true challenge, the creation of the mechanical soul that resides within these walls, is only just beginning. Now the locksmith transitions from heavy smithing to the delicate, high-stakes world of precision engineering, beginning with the construction of the wards, the fixed obstacles designed to block any key but the true one. In 1700, security is primarily achieved through complexity. The interior of the lock is designed as a three-dimensional labyrinth of steel, concentric circles, and geometric protrusions. The master takes a thin sheet of high-quality steel and coats it with a mixture of oil and lamp black, turning it into a dark canvas, upon which he scribes the intricate concentric patterns with a sharp compass. He is designing a negative space, a roadmap that the key bit must navigate without touching. Using a fine-toothed piercing saw, he cuts out these circular barriers, a task requiring steady hands and held breath, as a slip of the saw would not only ruin the piece, but potentially snap the expensive, fragile blade. These circular wards are then brazed onto the backplate around the central drill pin, creating a veritable fortress of steel rings. The smell in the shop shifts from coal smoke to the sharp tang of cutting oil and the metallic zest of fine filings. The complexity escalates as the master crafts the bridge wards and other irregular obstructions that will project from the lock's cap and sides. He works at the vise with a collection of needle files, some no thicker than a quill, shaping complex cuts and bridges that resemble the crenellations of a castle wall. He is effectively building a puzzle in reverse. He must visualize the key that does not yet exist, ensuring that the path he creates is navigable only by a bit cut, with mirror image precision. He constantly tests the spacing with calipers, measuring tolerances in fractions of a millimeter, or hair's breadths, as they are known in the trade. If the wards are too loose, a skeleton key or a bent wire could bypass them. If they are too tight, friction will seize the lock in damp weather. He bevels the edges of these steel obstacles to deflect crude picking tools, ensuring that a thief's pick will slide off the ward rather than finding purchase. This creates a psychological defense as much as a physical one. A picker inserting a tool feels only a confused jumble of hard stops and sliding surfaces, unable to map the internal geography. This stage of production reveals the hierarchy of the workshop. While the master designs the layout, the apprentices are often tasked with the tedious polishing of these internal wards, using emery cloth and oil to remove every burr and scratch. A rough surface inside the lock is a liability. It increases friction and provides a place for dust and congealed grease to gather, which could eventually jam the mechanism. The master inspects their work with a critical eye, running his thumbnail over the steel curves. Perfection is the standard. He then rivets the ward assembly permanently to the backplate. The sound of the riveting hammer is distinct, sharp, rapid taps that mushroom the iron pins cold, locking the wards in place with absolute rigidity. The result is a dense cluster of steel barriers, a mechanical maze waiting for its traveler. It looks chaotic to the untrained eye, but to the locksmith it is a perfectly ordered system of denial, where every millimeter of steel has a specific purpose: to say no to everything except the rightful key. With the static defenses in place, the locksmith turns his attention to the kinetic heart of the machine: the bolt and the spring. The bolt is the muscle of the lock, a massive bar of iron that will slide out to engage the door frame, and it must be filed to slide effortlessly within the case, while resisting immense lateral pressure. The master files the talon, the notch where the key will engage to throw the bolt, with extreme care. The geometry here is critical. The curve of the talon must match the arc of the key's rotation perfectly to convert the rotational force of the hand into the linear motion of the bolt without grinding or catching. But the bolt is useless without the tumbler and spring, the mechanism that holds it in place. For the spring, the locksmith selects a piece of blister steel, a material higher in carbon than the case iron, capable of being hardened and tempered. He forges it into a V shape or a leaf shape, hammering it gently to compress the grain structure, knowing that the life of the lock depends on this component never losing its tension. The heat treatment of the spring is the most chemically perilous moment in the entire process, where art meets metallurgy. The master heats the steel spring to a critical cherry-red temperature, and then plunges it into a bath of whale oil or tallow. The shop fills with a thick white smoke and the smell of burning fat. At this stage, the steel is glass hard, incredibly strong but so brittle it would snap like a dry twig if flexed. To give it elasticity, he must temper it. He holds the oily spring over the forge fire, watching the colors run across the polished metal surface. First pale straw, then dark straw, then brown, and finally a purple blue. He must catch it exactly at the transition to blue. Too soon, and it remains brittle. Too late, and it becomes soft and useless. He judges this temperature, roughly 570 degrees Fahrenheit, solely by the color of the oxide film, a skill honed over decades. A single moment of distraction means the spring must be scrapped. Once the color is hit, he quenches it again to lock in the crystalline structure. He tests the spring by compressing it in the vise. It must return to its original shape instantly, with a snap that speaks of latent energy. Finally, the tumbler is crafted, a small, pivoting piece of steel that acts as the gatekeeper. It is designed to fall into a notch in the bolt, locking it in the open or closed position until the key lifts it. In 1700, the fit of the tumbler against the bolt is the difference between a high-security lock and a common latch. The master files the contact points so that they mesh with airtight precision. There can be no slop or wiggle room. If the bolt moves even a fraction of an inch without the key, a skilled picker can use that movement to decipher the mechanism. He assembles the bolt, tumbler, and spring onto the backplate for a test fitting. The sound is the tell, a smooth shh of metal on metal, followed by a crisp, resonant clack as the tumbler falls into place. This is the heartbeat of the lock. He lubricates the contact points with a drop of fine clock oil or sperm oil, ensuring the action is silky smooth. The mechanism is now alive, a binary system of locked and unlocked, governed by the tension of the spring and the geometry of the tumbler, waiting for the only object in the world that can tame it, the key. With the lock's internal labyrinth complete, the locksmith faces his most exacting challenge, creating the sole object in existence capable of navigating it. He begins with a key blank, usually forged from a single piece of iron, with a bow, the handle, shaped into a trefoil or scroll design for leverage, and a cylindrical shank. Because the lock features a central drill pin for stability, the master must first drill a perfectly centered hole down the shaft of the key, turning it into a pipe key. This drilling is done on a lathe or with a bow drill, and if the bit wanders even slightly off-center, the key will bind on the pin and fail to rotate. The shank is then filed to a smooth taper, polished until it gleams, ensuring it produces minimal friction as it turns. The bit, the rectangular flag of metal at the end of the shank, is left solid and oversized, a blank canvas waiting to be cut into the complex negative shape required to pass the wards. The process of fitting the key to the wards is known as impressioning, a technique that relies on soot and silence. The master holds the blank key over a candle flame until the bit is coated in a fragile layer of black carbon. He then carefully inserts the key into the lock case and turns it gently until it hits an obstruction, one of the circular steel wards he installed earlier. When he withdraws the key, the soot is rubbed away exactly where the metal touched the barrier. With this map of contact, he clamps the key in a small hand vise and uses fine warding files to cut away the metal where the mark appeared. He cuts a slot, smokes the key again, inserts it, turns it a degree further, hits the next barrier, and repeats. It is a slow, iterative dance of smoke and steel. He is carving the key to pass through the concentric rings and bridges without touching them, leaving only enough metal to contact the bolt talon at the very end of the turn. As the cuts deepen, the key begins to look like a skeletal comb, fragile and intricate. One careless stroke of the file can weaken the bit so much that it might snap off inside the lock during use, a catastrophic failure that would require destroying the lock to fix. The master constantly checks the structural integrity of the remaining metal, leaving bridges of iron to connect the teeth of the key for strength wherever the ward pattern allows. Finally, the key turns a full 360 degrees without a snag. The sensation is distinct. A smooth, silent rotation followed by the heavy, satisfying thunk of the bolt being thrown. There is no grinding, no resistance, just the perfect marriage of two complex geometries. He cleans the soot off, polishes the bit to a mirror shine, and case hardens the iron tip to prevent it from wearing down over years of daily friction against the bolt. The mechanism works, but in the Baroque aesthetic of 1700, a lock is not merely a machine. It is a piece of architectural jewelry that signals the wealth and status of the owner. The master now turns his attention to the cover plate, the face of the lock, that will hide the ugly industrial guts from view. He cuts a sheet of brass or polished steel, shaping it to match the rim of the box perfectly. This is where the blacksmith becomes an artist. Using a burin, a sharp, diamond-shaped engraving tool, he pushes through the metal surface, carving out scrolling acanthus leaves, mythical beasts, or the owner's initials. He works with a magnifying lens, his hand controlling the tool with a steady, pulsating pressure, peeling up tiny curls of metal. The engraving serves a dual purpose. It is beautiful, but the textured surface also hides fingerprints and scratches that inevitably accumulate near the keyhole. He constructs the escutcheon, or keyhole cover, often a swinging piece of brass designed to keep dust, spiders, and moisture out of the mechanism. This small component requires its own pivot and spring, a miniature mechanism mounted on the front of the main plate. He rivets this assembly tight, ensuring the cover snaps back over the keyhole with a definitive click. The contrast between the cold, gray iron of the internal mechanism and the warm, glowing brass of the exterior is striking. He takes the internal components out one last time to clean them in a bath of spirits, removing every trace of filing dust or grit. He applies a fresh coat of beeswax and tallow to the iron parts to ward off rust, a mixture that smells faintly of honey and animal fat, the signature scent of a finished job. The final assembly is a ceremony of precision. The master places the backplate on his bench and begins to stack the components: the ward assembly, the bolt, the tumbler, and the spring. He secures the cover plate using decorative screws with heads filed into floral shapes or stars. These are not standard screws. He made the threads himself, and they are unique to this lock, adding yet another layer of security. A thief cannot simply unscrew the case without destroying the threads. He tightens them down, compressing the rim against the plate, creating a sealed unit. He holds the finished lock in his hand. It is heavy, dense, and cold. It rattles slightly, the sound of solid metal parts resting in their housing. It is no longer just iron and brass. It is a promise of inviolability, a dense block of kinetic potential ready to be mounted. The journey ends at the door itself, a slab of 2-inch thick seasoned oak, bound with iron straps. The locksmith arrives with his tools to perform the installation, a process as critical as the manufacturing. A lock poorly mounted is easily bypassed by simply smashing the wood around it. He marks the position on the inside of the door, using a scribe to trace the outline of the lock box. With a mallet and a sharp, wide chisel, he begins to cut the mortise, or the bedding for the lock. He works with the grain of the wood, peeling away shavings of oak that smell of tannins and age. He must cut deep enough so the lock sits flush and secure. but not so deep that he weakens the door's structural integrity. He drills the keyhole through the wood from the inside out, careful not to splinter the exterior face, where he will mount a decorative brass rosette to guide the key. He secures the lock to the door using massive lag screws, driving them into the oak with a brace. The torque required is immense. The wood groans as the threads bite deep, anchoring the metal box as if it were part of the tree itself. Then comes the keep, or the striking plate, the metal socket on the door frame that receives the bolt. He aligns this with obsessive care. If it is too high or low by even a millimeter, the bolt will jam. If it is too loose, the door will rattle, allowing a thief to insert a crowbar. He chisels the recess in the door frame, screws the striking plate home, and swings the door shut. The heavy oak meets the frame with a dull thud. He inserts the key. The metal feels cool and authoritative in the hand. He turns it. The sound is the final verdict. A heavy, resonant clack thud that vibrates through the wood of the door. The bolt has crossed the gap, burying itself deep into the frame, held fast by the spring-loaded tumbler. He tries the handle. The door is immovable, fused to the frame by a bar of Swedish iron. He hands the key to the owner, a transfer of power. In a world of rogues, footpads, and picklocks, this mechanism is a silent sentinel. To the thief outside, standing in the cold with his pick and tension wrench, this lock represents a riddle of steel he cannot solve before the watchman comes. To the master locksmith, packing his tools, it is the culmination of fire, filing, and geometry, a mechanical guarantee that what is locked inside will remain exactly where it belongs. True craftsmanship stands the test of time, resisting the rust of the modern disposable world. We are forging a living archive of human ingenuity here, but the bellows only pump if you keep the fire burning. You hold the key to the next chapter. Turn it by subscribing now. And before you go, tell us in the comments, what is one tool or heirloom you own that was built with this kind of uncompromising quality? Let's discuss the things that truly last.